Oh, okay. All right. They may show up with you don't have the thing to attach it. You don't have the adapter.
No.
Okay.
I have my presentation in the USB.
Okay.
So
Okay.
I just plug it.
Okay. It's not animated. I've got yours. I've also got the slides in PDF. You just present from the PDF. I don't know if you had animation. So then I could just pull it down from the email.
Yeah.
Yeah.
You can prefer not to.
It doesn't matter. Yeah, it doesn't matter.
Good.
Oh, I don't care about that. It's just, I'm just thinking which is faster for the changeover. Okay. All right. And, all right, it's 3:01. I guess we will go ahead and get started. So this is a tutorial covering two topics of emerging work in IEEE 802. So I'll do the first part and then switch over to Juan Carlos for the second part. The two topics we're covering are local address use and privacy. Usual disclaimers about that none of us speaks for IEEE 802, so these are our opinions. Okay. So I'm going to be talking about the IEEE 802 work on MAC addressing, and that's providing some structure to the local address space and providing for address distribution. I'm Pat Thaler. I'm chair of the Data Center Bridging Task Group, which also handles the addressing work, and a distinguished engineer at Broadcom. I'm also IEEE 802 vice chair, but I didn't put that on here because it's not as relevant to this topic. Okay, so this presentation is going to give you an overview of IEEE 802 MAC addresses and why we're doing some work on local MAC addresses. So IEEE 802 defines universal addresses and local addresses. So universal addresses are supposed to be globally unique. The two types of addresses are both 48 bits or 64 bits. We have both kinds defined. I'd say the vast majority of addresses actually in use today are from the universal address space. By the way, in some cases, they're called global addresses, so I might slip up and say global addresses as well, but universal addresses is the more usual term for them. The universal addresses have the UL bit set to 0, and they're called an extended unique identifier. That's a term that came along later. So, but you'll hear EUI 48 or EUI 64 depending on the length. 802.16 uses EUI 64, and there are some uses of EUI 64 as global identifiers for products that aren't, where it's not a MAC address, where it's just a product identifier. The other IEEE 802 standards primarily use 48-bit addressing. Local addresses bits have the UL bit set to 1, and up till now they haven't had any other defined structure. It's just a flat 46-bit address space plus the universal, local, and individual group address bits. The universal addresses are handed out in blocks by the IEEE Registration Authority, there's 3 sizes of blocks, and with the most common being the 2 to the 24th address block. So the first 24 bits of the address are defined by the value given by IEEE. That value is called an OUI, and an organizationally unique identifier, and has some other uses as well as address blocks, and the other 2 sizes are 2 to the 20th addresses and 2 to the 12th addresses, just so that if somebody only needs a smaller amount of addresses, we don't consume all the address, the full block of address space to give them some addresses. So let's see, the IEEE assigned bits include the universal local bit and the individual group bit. So the objective is to have this address space last at least 100 years. So MAC address consumption has been ramping up over time. When MAC addresses were first created, a company might get an address block and use it for years and years. As we started approaching this 2000, MAC address usage was on pace to last for centuries. But then we started putting addresses in things like this, and in TVs and in Blu-ray players and all those other fun things, printers, in some cases there's multiple addresses because they have multiple ports, and so that really picked up the pace. But even still, so at that rate of usage, it still looks on pace to last for 100 years. So that was a big uptick in usage, but not anything worrisome. Now we are starting to put network ports on things, on sensors and actuators. We've got LED lights that are getting power and control over the Ethernet cable. They use power over Ethernet, which can provide enough power to run an LED light, and some sensors and things, as well as the network. And some of these things are even disposable or short-lived devices. There's some medical sensors, for instance. And some things are virtual. You know, there's a lot of virtual machines that want MAC addresses. So when we start using MAC addresses at that rate, we can't do a global MAC address for every one of those things. A, it would run through the address space too quickly, and B, it's a manufacturing headache to have to give each one a unique address and make sure mistakes aren't made. So how do we enable using local addresses without having users or administrators have to configure an address in each device when they get it? The solution seems to be to enable local addresses that can be used without configuring them. So in order to do that, we want to have some structure to the local address space. Right now it's a big flat space, and basically the only usage of it right now is a local administrator assigns out addresses from it as they wish. Okay, so the first project I'm going to talk about is IEEE802C on local address usage. Okay, good. And the purpose of 802C is IEEE802 is the standard that kind of gives the overall architecture for the IEEE802 family of standards, and so that's the document this is going into. it provides an optional structure for the use of the local address space. Since the local address space has been around for decades now, we don't feel we can say, here's the way that everybody needs to use the local address space, and we're going to obsolete all the previous usage of it. There are other usages of it going around, even though it's not heavily used right now. So this will go in as an optional structure to use in a network for the local address space in that network. Part of the objective is to allow for coexistence of various address assignment protocols. So some people are likely to might use a generic kind of address assignment protocol, but there's also cases where people want to do a specific address assignment protocol for related to something else they're doing. So we want to allow for there to be multiple local address assignment protocols. So this is called I'm not crazy about this acronym, and this might get changed if somebody can come up with a better acronym. But it's called the Structured Local Address Plan, and it's currently at first working group ballot. So it's currently going out for kind of the first broader review in the working group. So this normally is a stage that produces lots of comment, and the details may change. So basically, right now this divides the address space into 4 quadrants. One is for a standards assigned identifier. So that's a space in which we'll write IEEE802 address assignment protocols to run in. And then there's an extended local identifier, which is a space for protocols that assign addresses out of a company ID block. A company ID block is something that any entity can get a block from the IEEE for their use. And so it's a 24-bit identifier, like an OUI is a 24-bit identifier, but in this case, the local global bit is set to the local value. And we'll also include in that some blocks for local administrator assignment. And then there's another block for administratively assigned identifier, and that quadrant can be used also for random address assignment. So if somebody wants random address assignment to where a device just randomly picks an address and goes and uses it, if they want that to coexist with some address assignment protocols, that has that quadrant. And then there's one quadrant that's reserved. No. I think that one worked.
Yeah. Okay. I just wanted to ask, how much space do I have for random assignments?
That would be 48 bits minus 4, so 44 bits. Yeah, 2 to the 44. I know there were some people who were only interested in a random assignment if they could get 46, but it's a pretty big space. The other project is IEEE802CQ. We're in the very early phases of. This project is multicast and local address assignment. And so this is to actually specify a protocol and procedure for assignment of locally unique addresses. So this would be a kind of generic procedure that you could use kind of regardless of what protocols you're running on those systems. and it applies to the assignment of individual addresses and multicast group addresses. And it would provide for both addresses for both address servers providing addresses and a peer-to-peer protocol where where a node tries to claim an address, and if there's a conflict detected, gets told that the conflict exists by the peers, and then tries a different address. So so there's two mechanisms for getting addresses that will cooperate. So a node might try to claim an address and get told, hey, I'm a server on this network. Would you like me to provide you an address instead? And so the idea is to keep those working together. And right now we are soliciting protocol proposals. I wanted to say this also applies to multicast addresses. There are cases where multicast addresses are used for a flow ID, for a time-sensitive networking flow, for instance. We've got IEEE 1722 that specifies audio and video flows and uses multicast addresses, and they've got a fairly lightweight version of an address distribution protocol in that, and so they're interested in using this. So we added multicast group addresses in addition to individual addresses. So that's basically the outline of it. It's pretty early days. I just wanted to emphasize here that not every device should need a global MAC address. We need to enable the use of local MAC addresses, and we're working on making that easier for people to do. So we don't want people to assume that every individual MAC address is an EUI or that every device has an EUI. And then I think I'll hand it over to Juan Carlos, and he'll give his presentation, and then we'll take questions afterwards. Oh, actually, I'm going to run that from my computer. Just 1 second here. Okay. Yeah. Okay. And I want that other one open. Here's your removable disk. There. Okay. Oh, you don't have the, you only sent, that's the PDF one anyway. Okay. Where's the thing to get that out? There. Okay. Yep.
Either Control L, I think, will do full screen.
Yeah. Okay.
Okay. Thank you. So I'm just going to hit. So hi everyone. I'm Juan Carlos Zúñiga. I'm going to present the second part of the tutorial on emerging technologies in 802, and my presentation is around the privacy recommendation project that we started in 802, actually in coordination with IETF. So I am here, the co-chair of the Internet Era group, but I was also chairing the privacy group in 802. I'm also working with the Internet Initiative of IEEE as an advisory member, and my affiliation is with Sigfox as a senior standardization expert. Oh, thanks. So I like starting with this quote from Olaf Kolkman, who's the CTO of ISOC, because it's interesting to first take people out of the technical context when we talk about privacy. He was asked the question once he was, I think, visiting a lab in Africa, when one of the experts asked Mr. Kolkman, do you think we can opt out of the Internet of Things in the future if I don't want my data to be available? And his answer was probably not. The truth is we are connecting more and more things, people, devices, and information is flowing all over. So we have to do this in a very conscious manner if we don't want to run into trouble in the future. So the idea behind this project is specifically to make people aware, people that are designing the protocols, of the potential issues that can come up in the future when information is no longer under control. So, well, Pat has already started talking about 802, but just a quick reminder for those of you that are not familiar. 802 is the group that is working on the lower layers. So you may be familiar with Wi-Fi, Ethernet, Zigbee, Bluetooth, all those brand names came out of IEEE 802 projects, and they are usually assigned a number, so 11, 3, 15, and so on. These groups normally define layer 2 or layer 1 technologies. We work together with IETF to define the rest of the stack, and then also with W3C to define the application in upper part of the stack. These three organizations work together not only to define these protocols, but also in the privacy side, we are coordinating efforts. So where everything started, I should say, well, privacy has been discussed for a long time, but there was really a peak in 2013 after, of course, the Snowden revelations and different issues that started happening. So IETF and IAB announced basically had a formal position against the privacy threat for pervasive surveillance. Then we had a workshop between the three organizations on strengthening the internet, and we discussed the different things that we could do in each one of the organizations. We created, well, there was already an executive coordination group between IEEE and IETF, and we have a topic coordinating privacy issues, and this is from 2014. And we also gave a tutorial to the IEEE 802 community on pervasive monitoring. Out of that tutorial, basically we created a group of privacy in IEEE 802. Coming back to what exactly we mean by privacy, we have to understand that this is basically more philosophical, if you will, but we have to focus on the individual. So by privacy, we don't mean we are going to defend organizations. We're not going to defend infrastructure. We're not going to defend a device. We are going to defend not only the user of the device, but individuals that can be surrounded by devices that may or may not belong to them. So that is something that we have to keep in mind. It's all about the individual. Then our discussion can very quickly turn into a legal, political, or philosophical discussion. We have to keep technical. So we define protocols in these organizations. We define internet protocols. So we have to understand what exactly are the issues that we have to attack. And this is, first of all, identifying the privacy threats, and then mitigating those threats one by one. And then basically that way we don't get into what is the reason of the threat, where it was the threat originated, if it's legal, if it's not legal. We know that in some legal frameworks, or actually in some countries, for instance, what is legal in another country is completely legal. However, the same device will probably be shipped to both countries or will travel with the same individual to both countries. So we don't want to get into those discussions about the legality or political reasons for doing or not. We just want to concentrate on defending the threats regardless of the intention of the attack. by threats. This is just a subset, but it gives you an idea of what we mean. It's identification, correlation, secondary use of the information, disclosure of this information, excluding the information, surveillance, so monitoring individuals, compromising the stored data, the intrusion, and the misattribution. So I'm going to concentrate on the first two, identification and correlation, because those are the ones more relevant for IEEE802. And for identification, we started working on this threat of tracking Wi-Fi mobile devices, and you might have heard that there were some issues where MAC addresses of Wi-Fi devices, primarily from mobile phones, were used to profile individuals without their knowledge. And there was this famous use case in London where waste bins were tracking past buyers, and then they were profiling them because the trash bins were correlating the information, and from the path, the walking path of the user, they could pretty much know where the user worked, where he stopped to buy a coffee. If it's in the city of London, most likely what kind of income he would have, what kind of age range. So the moment you know age, income, where you work, and where you live, it's pretty easy to find out who you are talking about, even though they claim that they didn't have a specific name attached to each individual or each profile. So that project actually got stopped, but that shows you how easy it is to basically build a system and start tracking people. We know those systems exist today in different frameworks, in public places, airports, and so on. The way it works is not only, as I mentioned, keeping track of the address, but also correlating with other metadata or information from the user, like the walking path, where he has been in the past. In the case of Wi-Fi, phones also broadcast the SSIDs of networks where it has been connected in the past, so you most likely have in the SSID, in the clear, the name of your organization, the company you work for, or your home, etc. So we definitely don't want people to know that a user is not at his home, or that he has or worked at a place, or he visited a coffee shop in the past. So the way we do that is by identifying what are the PIIs in the Internet of Things in this case. And PIIs are well known. It's personally identifiable information, and are well known when we talk about credit cards, medical records, IDs, passports, and so on. But when we start talking about the Internet of Things and all the new technologies, it's an interesting question. Would a light bulb create a PII? Would a microwave oven? A trash bin? Well, if it's in the middle of a street, probably not. But if it's a light bulb in a household, in a small room where, next to a baby, and the baby, the moment the baby is going to sleep, always the light turns from on to off, always at the same time, we are revealing information. If that type of information is traveling on the internet, we have to be aware that it may be misused. And again, it's not necessarily to the owner of the device, but the way the device is used. If someone is monitoring a house, and then they know that the shower went on, or that all the rooms of the house are off except for one, that's information. It's valuable information that we don't necessarily want to disclose. So we are talking about applying the privacy by design principles, and these are some principles that have been discussed in the past, and are pretty generic, but we try to make them specific for our protocols. So one of the principles is we want to be proactive, not reactive. So basically we want to predict, or as much as possible try to attack or defend the threat before it takes place or it's too late. We want to have the privacy as the default setting. So we don't want users to become experts in configuring their devices. We want the devices to be privacy enabled. We also want to have it embedded in the design. We don't want to be an add-on that you may have to purchase to be privacy enabled. We want to have a positive sum, so we don't want to definitely disrupt the business model of the company or whoever is buying, selling that device, for instance. The full life cycle protection, so understanding the information that is generated by the device, where it's going to be stored, how it's going to be used. So not necessarily stopping at the device itself, but also understanding that in the case of IEEE802, for instance, MAC addresses, they travel and they are used in IETF protocols. So we want to understand what all the life cycle protection of this information. We want to be transparent, so make sure that individuals understand that this is happening or this could happen, and if ever they want to disclose their information, because that could be the case in, I don't know, medical tracking systems and so on. The user may want to decide to be tracked. We want to make sure that it's transparent and the user is aware. And again, keep it user-centric, so it's all about the user. The mitigations that we can use, and this is pretty generic again, so it's an 802, but also an IETF. Well, first of all, data minimization. So if you don't need it, you should not necessarily have it or produce it. So avoid as much as possible the collection, the disclosure, sensitivity, and retention of PIIs. Make sure, again, that privacy is the default in our protocol. It's not something that it's an option that we have to turn on. And we want to make sure that the user is allowed to opt out, or in this case, could be opt in. You know, if we come back to the question before, does the user want to be tracked? I'm going to speak quickly about a privacy experiment we did in the IEEE and IEEE802 and IETF networks. We created a setup to test the feasibility of randomizing MAC addresses, and that actually became the permanent setup for both networks. So it is enabled now, so people can use freely MAC addresses without disrupting the network, and in both meetings. First of all, as I've already described, a Wi-Fi 802.11 devices expose their layer 2 address, which we think it's a PII. Well, it's actually a PII because it's globally unique, and it can be used to identify users. The way it happens, for those of you that are not familiar, is because, for instance, the phone, to connect more quickly, they scan actively for networks. So they continuously broadcast if the network is available, and by doing so, they disclose their identity as well as the previous networks that they have connected to. Some protocols in IETF make use of this information, like IPv6 address autoconfig, to create a layer 3 address. So that is again propagating even beyond the identifier, the unique identifier. We know that your organizations use this address or misuse actually this address. And at the moment, we thought that not all the solutions solve the problems. Now, fortunately, we see more and more operating systems and devices that do support the MAC address randomization. So I'm just going to quickly go through this because you already heard from Pat what a MAC address is, or how they are generated and how they are administered by IEEE. This is the structure. So Pat already talked about this. There's a first part that is assigned to an organization, and then the second part is the organization who uniquely assigns it to a device. So what we did is we have a paper describing the experiment, but we created this small software to run on Linux, Windows, Android, and iOS to allow the randomization of MAC addresses. And we experiment how it would work. And in general, there were simple rules like you don't want to change your address in the middle of a connection. You want to keep your address during the lifetime of the connection, not to disrupt the other protocols. But whenever you disconnected from the network, you would randomize again. And same thing when you were scanning for networks, so not necessarily in the connected state. We were able to randomize address every 2 minutes, I think. So we carried out the experiment at IETF 91 first. We created a separate network to make sure that we didn't disrupt our own network. we saw that it was quite easy to support just by tweaking the DHCP assignation and not running out of addresses, making sure that we are assign a shorter lease, DHCP lease to addresses that have the local bit set. So basically local addresses, in this case, random addresses. And then we were able to use the same DHCP infrastructure for both. And that's what we started doing as of IETF 92 and in the plenary IEEE802, which actually happened here in Berlin. Interestingly, we saw that even though we were randomizing the MAC addresses, there were some IP addresses that were still being assigned to the same device, despite the fact that we were randomizing the MAC address. After further investigation, we realized that the DHCP binding was not only taking place based on the MAC address, but also on other identifiers like host ID, client ID, and so on. So that rang the bell, and we are doing some work now for those of you that will attend the SAG meeting or all the security meetings, and even in the 6-man. We are trying to get rid of all these long-lived identifiers in our protocols, because they can be used to bind still the information of the user and track the user, despite the fact that we are randomizing MAC addresses or IP addresses. So lesson learned, we cannot work in isolation. We have to make sure that privacy is fixed in all the different protocols and all the different parts of the stack. And that was basically our conclusion. As I mentioned, in this case, well, the week is the beginning. So if you hear, about identifiers, host IDs, identifiers in the DHC group, in the SAG, we're talking about the MAC addressing and other ways to get rid of these identifiers is definitely a follow-up of all these discussions and experiments that we have carried out. And the future work, well, again, the IAB is doing some statements on the best use of the protocols. We have specific work taking place in different groups. And in IEEE802, we created this IEEE802E work that is defining the privacy threat model and the recommendations for IEEE802 users. And that is in coordination also with the work that Pat just presented, the 802C, which will take care of defining a space, as the question was asked before, a space where we can randomize MAC addresses. Thank you very much. So I guess we still have a few minutes, right, for Q&A?
Yes, we have.
And there,
Plenty of time.
we were asked to put that link to a Survey Monkey for you guys attending this tutorial. If you think this is of use or not, that's helpful for the IETF organizers. They want to understand if it's good to keep giving these tutorials about topics that are not related to IETF, or if there's ways to improve them.
But related to, but are an IETF project. So, yeah. Okay. So are there any questions? Yes, please come to the mic.
If you can check it that it's turned on, please.
Now it's on.
Yeah, good.
Okay.
Could you please take your name first?
Yes. Thank you for the presentation, both of you. My name is Panos from Greece. I'm a policy fellow. It's my first meeting here. And I would like to ask you a question regarding the privacy that you said before. Here you are producing standards. So these standards are going to be used in all over the world. But the regulations about privacy and how to use the data for the privacy are not the same all over the world. They are different in Europe, in America, in Asia, and elsewhere. So are there security measures from your side? So these standards that you produce here about privacy to be let's say, adapted according to the regulations, the policy regulations that each country have. because each country, as I said, has different legal environment. That is my question. Thank you very much.
Thank you. So the short answer is no, because it's very difficult. And as you say, there are very different legal frameworks in the world, and often they are even contradictory. So, and you know that the reasons for, one country tracking users may be completely different to the reason for another country tracking users, right? And this same standard has to be used in Beijing, in Moscow, in Washington, and in Ottawa, and Mexico City, right? So we know that unfortunately that the reasons for tracking users in all those places are very different. And it easiest is to not basically take any party, just say, okay, well, we're going to make sure that this technology cannot be misused in the future. And then we don't want to get into the argument of whether this is going to be used by a governmental organization, by a criminal organization, by a commercial organization using privacy unfriendly, ways. So we want to avoid all those legal political discussions, and we just want to make it technical. So when you talk about regulations, complying to a regulation, that is different, because it could be, that is when you design the system. Sometimes you have like legal intercept type of things, that are well known. When you define, for instance, cellular system, you maybe have to provide a hook to the enforcement agencies to track a call, for instance. Well, that's part of the whole system, but at least we don't leave a hole in which, without necessarily wanting to, a user can be tracked by an external system, right? So once you put the system together, you may run into regulatory issues, but I don't think that at the protocol level, this is something that we are going to face.
Or give the individual the capacity, let's say, not to be tracked. It's not a part of the protocol, I assume.
Yeah. So again, the protocol, what we want to avoid is ways to track people without necessarily the intention to do it. If you want to enable the system to have a legal intercept feature, well, then you define it, and then you make sure that it's worked in a way that it's correctly used and for the purpose that it was designed for in a closed system. The problem here is that these are internet technologies that are used left and right, and there are several implementations that can be misused. So that is the first.
I understand. Thank you very much.
Thank you.
Lorenzo Colidi. So if you're building a client like a mobile...
Can you state your name?
Lorenzo Colidi.
Okay.
If you're building a client operating system, you have to weigh privacy against maybe other parts of the organization or of the team or whatever who are trying to optimize connection time by reusing previously used identifiers, doing things like DNA. And you're also trying to perhaps meet some enterprise requirements that say you must always be trackable on my network. Is there some sort of place where we're discussing those sorts of trade-offs? Because at the end of the day, if this doesn't make it into implementations by default, it's actually not going to go anywhere. And personally, I would like to see this. For example, I would like to see the mobile operating systems do MAC address randomization by default all the time. But there are system level challenges that you dodged right now when you said, when you build a system, you have to deal with some of these problems. But do we have a place where we're discussing these problems? Like, do you have something that I can show my boss and says, look, here's all the scary things that will happen to our users if we don't do address randomization, for example?
So, well, I heard two questions. So,
Yes.
so first, you were talking about the way we can make this happen in real commercial systems, for instance, and then that we did discuss solutions where we can make profiles, for instance. We understand that today's network, for instance, when you connect to the hotel, you might want to keep the same MAC address when you connect to the hotel, because otherwise, if you pay for the the Wi-Fi through the week, they usually recognize you through the MAC address. So you don't want to change that MAC address. As long as you tell the user, well, do you want to keep the MAC address for this network? Then it's pretty easy to make a profile and then keep coming back to the same MAC address in this specific use case. And that can be used also for connecting to an enterprise network where you are also authenticated through the MAC address and so on. We had those discussions actually in the INT area before, and Christian Witema had a proposal where he actually said that Windows 10 already supported some sort of profiling. It's not in the realm of us to define that profiling, but that discussion did take place at one point in time, and even in the, I think in our experimentation we were talking about ability to make profiles. So I don't think that there's a forum where we can talk about it.
Did that result in a document, that discussion in INT area?
There was a presentation, and I think that the end result, well, Christian has a couple of documents. One of them is the DHC host ID, but that's more specifically just talking about this one issue. Probably in the introduction, he does mention, the overall problematic. But if I remember well, in interior, it was only slides that he presented.
Okay.
Yes.
I'm Ed Barrowset. My question is whether it may be too soon, but if there's a way that you can generalize what you've discovered about trying to bring the possibility for privacy into protocols that we're working on here, are any things that you've observed that if you were going to say, if we had started originally with this in mind, we might have done it this way?
Well, probably, if I understand the question, it'll be around the privacy by design principle. So I don't think that those were present in people's mind when we started working on these protocols, and furthermore, these protocols were sometimes used for local cable connections, and now they are broadcasting information with radio in the clear. They were meant for computers, and now they are being used in cell phones. So I think that if I understand your concern or your question, it'll be around the privacy by design, that we did not have those principles in mind, and we thought that of a closed system that did not have any risks, and all of a sudden those became risks. So we're trying to patch the system now, but ideally we don't want to create more risks in the future.
Yeah, what I meant in particular was I've read a number of privacy by design articles and a book. How that applies to the creation of protocols that we might do here at the IETF is maybe a little less clear to me, generally speaking. And I was just curious if there were specific things, like you mentioned the long-lasting associations might be counterproductive if one of the goals is privacy. And it was that kind of more specific thing I was curious about.
Well, that long-lasting identifiers is quickly said, but actually more and more we discovered that they exist in more and more protocols. So that is the current discussion that we have. People realizing that now in layer 3, but by the way, in layer 4 as well. No, actually we use it now in layer 4 and beyond application and so on. So that is one. But probably in the future we will find out that there's more than IDs that we have to work on.
Good afternoon. My name is Ahmed Aldabar. While I understand the randomization and the need for privacy and so on, from just what I got is that you're protecting from an external threat as opposed to an internal thing. I still believe that there's a need for some sort of auditing and troubleshooting, engineering troubleshooting. There's a particular device which is not working properly. With the sort of techniques that you've been discussing, that's going to become more and more complicated. So what provisions are you thinking to maintain some sort of auditing capability for whatever sort of engineering or even, for example, pricing costs kind of thing? Thank you.
Well, those discussions usually don't take place here. Of course, offline we can discuss all of them, but the commercial implications are only considered to the point that if we talk about encryption, for instance, you might need to have a more processing power in your system, and then that could affect the cost and so on. So we may want to consider that when choosing different type of encryption and when we talk about specifics like that. But beyond that, I don't think that this is a discussion that normally takes place in this fora. So it'll be more in the, I guess, industry organizations who will decide on those. And by the way, encryption is the other word that the IAB keeps using. Keep using encryption. Don't send data on the clear. Yes.
My name is Reem. I'm here representing policymakers from Bahrain. My question is not very much related to policy, I would say. It's more of a out of curiosity, out of the discussion we have today.
Can you get closer to the mic? I know it's high for you. I
Maybe
would have
now?
the same problem.
Now? Is it better?
Yeah, that's better.
I've always thought I'm tall enough. But anyways, the question I'm raising is out of curiosity that I just derived from what you've been discussing. When you spoke about privacy by design, as a user, how would a person make sure that their privacy is protected when they tick the privacy box, basically? With the reason why I'm asking this question is because with the buzz Pokemon Go game is going around, I was one of the people who've downloaded the application the first day the game was launched, but I was too scared to use it after the controversial discussions have been coming out about how data is going to be used or may be used in terms of tracking. So guidelines in such a way might be helpful if possible. Thank you.
Yeah, I think that falls more in the realm of W3C, but in the applications. In our case, when we talk about the tick, and unfortunately today we have several ticks, right? There's privacy for this application, privacy for your Wi-Fi, privacy for this network, privacy. So we want to avoid the fact that users become experts and they have to search all over the place and tick to make sure it works. You raise a good point that how can we protect future applications popping up and then disrupting the whole privacy protection system? And we think that at a certain point we would like to have a correlation so that if the user has a profile that says I don't want privacy to be enabled, then he's reminded, okay, well, if you download this application, be aware that you are against your own decisions in the past. That could be a solution, but again, that's pretty much at the application layer. W3C has something to working on that with the web browsers, for instance, the privacy, the privacy mode, or the this other checks that you do on the browser, where the browser tells the website. That came out of those discussions, but still not enough, unfortunately.
Yeah, IEEE802 is dealing with the layer 2 protocol, and so our objective is to avoid your device leaking data kind of to the world as you carry it around at layer 2, which is a totally different question than whether an application that's using GPS and that you're logged into as a user of that application, are you willing to let that know your GPS location?
What is my daily routine, basically?
Yeah. And I would say, by the way, that's much less of an issue with Pokemon Go than it is with Ingress. Because Ingress, it puts out on COM where you were, and somebody can see where I went around on Ingress. But that's also not today's topic, because that's not a layer 2 thing. That's an application thing.
Lorenzo Coludi again. I would actually like to put in an impassioned plea for you to not ever say that, because
To not ever say, sorry.
not to say that the problem is a bit above layer 2, because and therefore cannot be solved at layer 2. And the reason I say that is that I think if we have strong security and privacy at the lower layers, it becomes much easier to build the higher layers to rely on that. Because like one discussion that we're having right now in the 6-man working group is like, we can't trust MAC address randomization to be in place, so we must randomize our own identifiers. And if you look at it from a holistic point of view, like if you're building an operating system, you say, look, that's a stupid thing to do because I have to randomize at 2 different layers because I want to protect against the lower layer, against the layer 2 threats, because they're very dangerous. And I also want to protect against the layer 3 threats. So now I have to implement randomization in 2 places. Whereas if I can rely on layer 2 randomization, it's way stronger than doing it on layer 3, right? There's a good reason why we don't implement checksums in HTTP, because it's done by, and so it would be nice if we could rely on this stuff being robust at layer 2.
I agree, and I wasn't saying that we shouldn't, but given that you have your own device knows your GPS location, if you no matter what we do at layer 2, if you're logged into some system and sending them reports of your GPS location, nothing we do at layer 2 is going to undo the fact that the system you're logged into
I guess
knows your physical location because you logged into it and are sending it to it. But that's not, there are problems we can say we can and should solve at layer 2, and we shouldn't be leaking information, but
I think there are 3 categories of problems. There's stuff that you can't fix at all, like the GPS problem that you just mentioned. I agree 100% on that. There's stuff that you can't fix 100% because it's at lower layer. And I think that there's stuff that you can fix if you do a good job, even in the layers above you, like this case of IP address device identifier randomization.
Yeah, okay.
I would encourage you to maybe think about those a little bit as well, because a solid lower layer security is always a better foundation in my mind than redoing it at the layer above.
Sure.
Yes.
Hello, good afternoon. My name is Greg Mooney. I'm also a public policy fellow. We've been talking a lot about privacy, and there is also a similar concept, which is also equally very important for society, and this is anonymity. And I was wondering whether do you have a work strand on trying to protect anonymity as well, or is it something that you don't deal with at all?
I think, I think we include it as part of the privacy. So definitely, if we want to keep users anonymous, then that's a way of providing privacy. There's different ways to do it. But I don't think we necessarily talk about the fact that anonymity, because as we said, sometimes we want to turn it on or off, or tracking or not. So we want to be a little more specific about that. But I think privacy, identifiable information, englobes, the fact that we want to keep anonymous users that are not aware of it.
Thanks.
Okay. All right. So
Yeah,
we're
I think
2 minutes to.
I think yes. So just reminding you again that the Edu team likes feedback on how people felt about the tutorial. So there's the survey information there, and thank you for your attention today.
Thanks a lot.
Oh, that was good. That was well timed.
Thanks. Yes.
I was a little worried there weren't going to be any questions.
Thanks for the.
I didn't get any about addressing other than the
Well, it's part of it.
It's a more boring topic. Yeah.
That's part of it. Thanks for the support. Thank you.
Okay. Yes.
Hey.
Yes.
Yeah, I didn't attend the IETF meeting for several months.
I see that. So you're still doing peer-to-peer?
The good reason
You
would
have
be
a
to not end up with
So you
duplicate addresses with something that's assignable.
still based in your place?
I am, but